So normally I have like 25 slides. I only have 3 today, so that's good news. Which means, and we have plenty of time left. So as I go through, please feel free to ask questions 15. Or make comments. We have a lot of folks here who know Spectrum very well, may have a different opinion than I do. And for that matter, you could, if something I say triggers a question for Dave or Dewey, that would be fine as well. So I actually did a talk yesterday on 4G and 5G spectrum that really just focused on applications where the decision had already been made. They were going to go 4G or 5G, and what spectrum was available. I talked about 8 different bands. I'll focus on just 4 today. We really have 4 that are widely available for 4G, 5G spectrum. And then I'm going to talk about 5 bands that are for more traditional networks. There's overlap there in one of those bands where it could be, it has been used actually for each. And then I won't go through, or don't plan to go through this additional bands to watch. There's 4 additional broadband bands that are maybe becoming available, partially available in some places. And if there's time, we can talk about those as well. I didn't bring a slide for those. So here's the bands. I'm going to start with the traditional private network. I guess first of all, maybe I should say, is there anything, anyone who wants to mention a band that's not on this list that I think is quite relevant for private networks? Okay, get another chance later if you want to do that. All right, so once Dewey had made the decision to look at what was available in terms of traditional networks, he had a list to go to. PG&E a long time ago had made the decision for narrowband PCS, so this one on the far right was there and available, and that was a good place to start. They talked to us about spectrum. I don't really think there was much VHF 150 megahertz available in your operating areas. There are some significant issues with noise in that band. It's been used by a long time for a lot of people. It propagates very well, but that can be your enemy on the interference side. So that really wasn't an option. He mentioned ultimately, I'll just go across the spectrum band here from left to right. So he mentioned eventually they ended up on 220 megahertz spectrum. This was available in their operating area. It's available in substantial portions of the country. Excellent, obviously, propagation. Going to go a very, very long distance. Good, I would say, in terms of this kind of general ranking, and a lot of this is kind of qualitative, right, as we're trying to do comparisons, or relative, maybe is a better term, between the different bands. But it could do the channelization they needed. It couldn't do super wide bands, 50 kilohertz. You get reasonable throughput there for a typical fan type operation, particularly in more rural areas. It handled the data rates that they needed in those areas. I guess I do have a question that I'll ask when we're going through this. Do you see this as more of a rural solution or urban solution? How do you see this fitting into PG&E's network? Is this in San Francisco as well?
Is this the thing on? Both. It's okay. Both urban and rural.
Okay. We heard obviously that he'll want more capacity over time, right? And so they're looking at that solution. It is widely in use for both voice and data type applications. Well, I'd say widely in use for data. Available in voice is probably a way to say it, and certainly could be used for backhaul given the moderate requirements. In the Part 22 VHF, that's available in certain portions of the country. We did a transaction with WEC this past year. Dave was involved in that one as well. It was not really available in California, and I'd say that more often not available than available. It's just a question of who has it, are they willing to part with it, is it still licensed. So I think we have a significant inventory. There may be other places where you can find that as well. But but potentially good. And mostly we see this being used in the voice side of the world rather than the data side of the world. So the upper 700 megahertz A block would have been, in my opinion, even better in terms of capacity for sure for what PG&E did, but California High Speed Rail purchased that from John Vislowski of Access Spectrum and myself for Select Spectrum a number of years back, and so was not available in California. But had it been available, it has the most overall throughput. It has a great ecosystem, lots of different equipment suppliers. The channelization, you have quite a bit of flexibility to go up to channels that are 100 kilohertz. Wide use in data. This is held by about a third of the utilities and critical infrastructure around the country. And this is the one band that also I would call it mostly used in traditional networks, but it is part of the 3GPP standards as NB-IoT. So we also did some discussion of that. It's different characteristics. It tends to be lower speed, but very long propagation, good battery life, could be used in situations where you don't really have electrical power to the remote entities of gas meters, sensors, that kind of thing. So could have been a very, very interesting solution, but has already been acquired. Still available in 2/3 of the country, so still a good opportunity. And then we mentioned the narrowband PCS at the beginning. It's already been acquired, so a good solution. So questions or comments about this slide? Remember, there's only one more after this, so now's a good time to ask if you have any. All right. So
can I editorialize for a second?
Sure, please.
On the spectrum front, it's also important to, I would say, keep up to date on what's happening with the offerings, because we had been looking at this 220 megahertz spectrum, 217, 219 to be, I guess, technically more accurate, for quite a while. So some of this spectrum stuff, it changes over time.
I'll make a plug. We do have a website, selectspectrum.com, that has a listing of what is actually available through us. We're certainly not the only source, but it's a place that is worth checking. Any other questions?
Question for Julie, actually.
Sure.
Did you find that more radios became available also? Infrastructure for 220 once the spectrum was more available?
I think there's been a fairly good ecosystem out there, because that general 200 megahertz band has been available from different manufacturers for a while. So GE, like for instance, has had the SD2 radio. They've got an SD1 for the 100 megahertz, and it's programmable anywhere in 100. They got the SD2 for 200 megahertz, and SD4s and SD9s. So
yeah, and I'll echo that. We've for years found a good ecosystem there, and MIMO-MAX has introduced a whole series of products on the 220 band, and have done some pretty remarkable things with antennas too. So you can get 220 from MIMO-MAX, 4RF, GE all day long.
220, any problems with interference with positive train control?
So from our perspective, the positive train control, so they're actually running on the Choctaw spectrum. So there were 2 blocks of AMTS. Havens had 1 block, Choctaw Telecom has the other block, and Choctaw sold one whole side of their spectrum to PTC. So from a interference perspective, we really don't see issues with PTC. The issues we see with 220 is the very thing that makes it really cool, that it propagates like a bat out of you-know-where, also makes it prone to interference. And if you happen to be in a high sunspot cycle or the recent solar flares, then suddenly you've got I'm an old ham, what us old hams used to call skip, or the CB guys called skip. You start hearing 220 from halfway around the world, and that becomes more of an interference issue. But all 3 vendors have built enough interference sensing, forward error correction, modulation drop back software into their radios, that the radios work pretty good. From a user perspective, what you see is things slow down a little bit versus things becoming non-working. And Richard, you're the expert there. Anything I should say or didn't say?
you have to be concerned about low power TV and whether or not you're going to interfere with it, or if there's might be something that's close enough to you with enough power interference into some of your remotes.
Yeah, and that's a good point. So the other thing about 220, and this is another place where you want a good consultant on team, is for any AMTS spectrum, you have to do what's called an FCC TV study, and you have to go look at the potential for you to interfere with TV stations 10 and 13. If you have a local high power station, there is risk that they could cause you some heartburn, but typically not, because the reason we're doing the FCC TV study is we are, and this may not even be true anymore, but I don't think the FCC's changed the rules. In the digital days, this may not be an issue, but in the analog days, we were 2 IFs away from the channel. And again, those of you who are old hams or old engineers, and you're dealing with a superhet radio, if you're 2 IFs away, basically you look like an image of the same channel. And you come through as though you were on channel, even though you're 2 IFs away. And that was the reason that you had to do the FCC TV study. It's not a big deal. It's an arcane piece of software and a bunch of hand-wringing and jumping through hoops. But at the end of the day, what it means is if you calculate you're going to create too much interference, you have to add more filtering to your system. And you have to commit that if there is interference that gets reported, you'll go fix it, which typically means putting a filter on the back of the TV of whoever's reporting the interference, or on the antenna feed-in of whoever's reporting the interference. But it's typically a broadcast issue. It's not a cable issue. So in today's world of digital and cable and streaming, it's almost a non-issue, but the FCC still requires you to go do it.
Make a general comment about driving equipment vendors to support the different bands that are relative to utilities. I spend half of my time on working with suppliers to make them, encourage them to work to develop changes so that their equipment works with the frequencies that are available to utilities. And to the extent utilities can help make that happen, that's very much appreciated, right? Feel free to speak up. If you've got a block of spectrum available, but there's not equipment, or not, you've got a supplier that doesn't meet that band, work in that band, please speak up and talk to them. All right, we will move forward to 4G, 5G solutions. This is obviously very much of interest. I saw the number of people streaming out of the last presentation. It was very strong. I mentioned today we'll really talk about the 4 band. So quickly I'll go through the 700 megahertz. This is a band that's been acquired, I think, more widely by utilities over the past 7-8 years than any other band. It's widely available. Almost all of the implementations so far have been on traditional private networks. But UBIC is now building a base station. There's chips and modules available from a number of suppliers. So I certainly encourage you to look at this for NB-IoT, or potentially for those who already hold the spectrum. If you're not using the entire block, you may have the ability to put in NB-IoT on a portion of it. And in terms of very long distances, sensing, low speed, some latency, this is a different solution, and potentially a very compelling solution. The endpoint should be quite a bit less, right? Because we're dealing with a chip that's, $20 chip or something like that. Goes in a module, is $50 module. Heck of a lot less expensive than the traditional private radio endpoints. And this doesn't necessarily need to have a full core, it can be a simpler implementation than some of the other broadband 4G, 5G. So in terms of 900 megahertz, this, band 106, formerly band 8, Anterix, has obviously generated a lot of excitement in the industry. I think they have a half dozen sales and leases done so far. Excellent propagation at 900. There are some issues in terms of it's in a noisy environment. We saw a little bit of that at UBBA last year in Minneapolis. Obviously, difficult situation where everybody's coming into an auditorium type environment, trade show floor. So that may not apply in general, but it is in an environment where there are lots of adjacent operations So, something to be concerned about, at least to be aware of. 3x3 so far, application to go to 5x5. In either case, they have clearing that needs to be done. I think that's a significant issue, and Tarek says it's no big deal. So please, check into that and make your own decision about that. Good in-building penetration, or excellent in-building penetration. Good throughput, I would say, and this is in a comparison of the different bands here, and that's overall description of 900. We'll take comments here or questions as we go through. So we are representing band 54, held by Legato Networks. So this is a time division duplex band. It's 5 megahertz so far. There is likelihood of going to 10 in the future over the next several years. It has, I would say, very good throughput, in part because of the TDD nature of the band. So even if you had 100% uplink, downlink, you're still going to get more throughput on the downlink than the uplink, because you're going to have different modulation depending on what the endpoints are. Not a big difference, but some difference. In the case of a time division, you can look at what your uplink, downlink ratio is. Most utilities have more up than down, and set the threshold, so the timing, so that you're using more time to go up than down, and therefore you can actually generate more throughput, materially more throughput on the uplink in 5 megahertz than you could in a 3x3 band for FTD. So significant difference there. Available today, the clearing involves Legato's operating the existing network. So they call the guy who's running that site. You say, turn down the site. The next day you can be in operation. So not as significant an issue. And then it's a quiet neighborhood, right? There's no competing terrestrial networks surrounding you. It's listening for space, listening for ET on the low band, and weather balloons are on the high band, and that, obviously relatively low power type situation. So we think potentially very exciting band for utilities. We're talking about ecosystem. We're working very hard to move that ecosystem along, and I'll be glad to talk to you about the progress we've made. We think it's significant. Many parties here probably are operating on CBRS or the predecessor in 365. Excellent spectrum in terms of throughput, 10 megahertz channels, time division duplex, so it has that advantage as well. The power is limited. There's some work to try to get some site installations to have higher power limits, but for now it's limited. So between low power limits and the nature of 365, right, 3.55 gigahertz, it's not going to have the best propagation. We see this as a solution for a substation or a depot. We don't really see it as a solution for widely available, covering your whole network. But we'll be glad to sell you a PAL, right? And we have them available, and that will give you priority access over the GAA tier. So it probably doesn't matter down in the canyons where Dewey's hydro stations are, but in many places where you're trying to manage a substation or something like that, the priority access license could be useful. And we will split these down to whatever size makes sense. Right? We're actually working on a software tool that will allow you to do that over the web. So you could buy what you need as opposed to buying the minimum of a county, or lease what you need. Again, we think the noise floor would call it good here. It's managed by a spectrum access system. You're going to have to pay a little bit more for that. So I think your spectrum cost would be maybe lower than what you were talking about there in CBRS. You'd have some ongoing costs, and obviously you buy a lot of sites to cover your territory in CBRS. So, all right. Questions, comments on this slide or in general?